All right, so we're finishing up Space Shuttle. Our space shuttles are over here, and we've done the top and the middle, and we have left to do the bottom, which is here, or the base. We cut it into 3 parts, so I have 3 videos. In the third part, it's actually the most complex part because the spaces in front are dependent not only on size, but also on what row we're in. So before we get there, let me just go on to paper. And again, it doesn't hurt to just use a new piece of paper for each of these when you're doing this type of work on your own. If you have too much stuff that you're looking at one time, it's confusing. But if you actually just look at one thing at a time, so right now we're looking at the base, then if the other parts are done, all I need to do is the base. The other advantage of this is sort of compartmentalizing this problem into 3 different parts. You know, if you were working on a team, one team could do the first part, another team the second part, and a third team the third part, and then you bring them all together and it's going to work. So this idea of sort of doing this one method at a time allows us to work on things both independently, but also in groups, which is what most working environments actually are. Okay, so the base has 2 rows in size 4, 1 row in size 2, and I'm assuming it's 3 rows in size 6. Double check that. Good. And then so there's a loop there, and the loop is for each of these rows we have to do some stuff. So for row equals 1 to, what's that linear relationship? Again, if you can look at it and see, well, each of these rows is half of the size. So this is half times the size. If you want to see us go through it like we did before, the slope, the change in y over change in x is 1/2. These change by 1. These are changing by 2. This is x, and that's y. And the y-intercept, if you go back up to size 0, that would go down by 2. This would go down by 1. You'd get 0. So y equals mx plus b, or rho equals 1/2 size plus 0, which is this. Okay. So then on each row, what prints? Well, we first print spaces. Then we print forward slashes. And let me just make that a capital forward slash, spell it out. Then we're going to print the percents. And then we're going to print the backward slashes. And then we need a print line at the end. And all of those things are happening on one row. You know, if we wanted to, these could each be a function, but you know, we're not calling them more than once. So we're not really saving anything by doing that, except making it easier for the reader to kind of see what's going on. So maybe we'll do each one as those 3 functions, or we could have 4 functions really, spaces. You know, that doesn't hurt. It just adds more compartmentalization. I haven't decided whether I want to do that or not. So let's look at the spaces first. And exactly right, I need to scroll down and I need to consider that my spaces, my pen is misbehaving here. Okay, my spaces depend on several things. They depend on the size, the size and the row. and the space. So just so we can see this, and maybe it's not as important here as it will be in later projects. In size 2, you have one row and there are 0 spaces in the front for the base. In size 4, you have a first row and a second row. So when I make my table, I need to take into account that for size 2, I have different rows, or for size 4, excuse me. And same thing for size 6. We have 3 different rows. So in size 4, the first row has 1 space in front. The second row has 0 spaces in front. In size 6, you have 2 spaces in front, and then 1, and then 0. Let me double check that. 1, 2, yep, 1, yep, 0. Okay. So the question is, how do you make space as a function of both the size and the row? So again, if we think of it as a linear function, space is still going to start at 1, 1, 2, well, to what? To something here. Okay, so what we're going to do is we're going to think of first the linear relationship between the space and the size to determine our slope. So at size 2, we're starting at 0 spaces. Size 4, we're starting at 1 space, and size 6 is starting at 2 spaces. And that slope if we think of this as a linear relationship, y equals m times x plus b, essentially what we're going to do is we're going to find m, but then we're going to let b itself be a linear relationship on the row. So we're first going to find this m as it relates to the size. So the size here initially this is a change of 2, and these are changing by 1. So that slope is 1/2. So I'm going to write this in words. The space is equal to half the size plus something. And now I'm going to scroll back up. If you take half the size here, you get 1. What could you add to 1 to get 0? You'd have to add -1. Or if the size is 4 and you times it by 1/2, you get 2. What plus 2 will give you 1? So this one over here, again, it's -1. If the size is 4 on row 2, half of 4 is 2. What plus that 2 will give you 0? For this 0 over here, 2 minus 2 equals 0. So, and then let's go to here. So if my size is 6, I take half of 6 is 3. Notice 3 minus 1 is 2. 3 minus 2 is 1. 3 minus 3 would be 0. So this guy over here is going to be -1 times the row. Now, how did I figure that out? I'm not sure. I think I did 2 things. The first thing would be if I go back up here to 0, that would be 0. This would be -2. So we'd have like a -2 here. And then if I look at, say, this relationship here, I can see that these are increasing by 1 and these are decreasing by 1. So that's the slope of -1 times the rho. And then if you went back up here to 0, this would have to go back up here to 3. So you'd have a +3. Hang on one second. Okay, sorry, I got a little confused. I made a mistake. They happen. This is not right here, and this is not right. So if I wanted to find the y-intercept when I'm looking at sizes, I need to think about that, not looking at when rho is 1, but when both rho and size, when the rows are 0. So in size 2, 4, or 6, with a 0 row, for 0 rows here on size 6, we would have 3 spaces. For 0 rows in size 2, this one would go down by 1, that one would go up by 1. We would have 2 spaces, in size 4, excuse me. And in size 2, it'd be 1. So if this goes down again to 0, that's going to go down also to 0. So this is plus I. Plus 0 here, not plus 2. And then that makes sense, half the size minus 1 row. So maybe a little easier just to think about it in terms of total number of spaces. Let's look at it again. Space, size, excuse me, I'm too fast. Size, row, and space. Size 2, there is only 1 row and there are 0 spaces. Size 4, we have to look at with 1 row or 2 rows, and there are 1 and then 0 spaces. And size 6, I'm just redrawing that same table. You have 1, 2, or 3 rows, and you have 2, 1, 0. So the slope in the relationship to the size is 1/2. So you go from 0 to 1, 1 to 2. Over there and over here you go by 2s. So again, it's the space equals 1/2 the size. And then you're adding something to that, and what we're adding to it is dependent on the row. So now when we look at the rows, well, half of 2 is 1. To get to 0, you'd have to take 1 away. So that's, or look back at the relationship between the slope here is 1, when this increases by 1, or look at the bottom one. As the rows increase by 1, the spaces decrease by 1. So the slope is -1 times the row, and then you still have to figure out the b value, but in this case, the b value is 0 because when you take half the size, half of 2 is 1, minus 1, you get 0. Half of 4 is 2, minus 1, 2 minus 1 is 1. Half of 4 is 2, 2 minus 2 is 0. Half of 6 is 3, 3 minus 1 is 2. Half of 6 is 3, 3 minus 2 is 1. Half of 6 is 3, 3 minus 3 is 0. Okay, so we have, going back up, we're trying to develop this code for spaces that goes inside our loop of rows. All of this is inside of base. So middle, base 4, integer row equals 1. We wrote this all down so we could go back to it. Up to half of size, or 0.5. 0.5 times size. Increase the rows by 1. Then we have a second loop for the spaces, which go from spaces, integer spaces equals 1 up to half the size minus 1 row. That's tricky. So again, I'm going to use 0.5 so I don't have to deal with 1/2 being 0. 1/2 the size. Oh, it should be negative, I think. Nope, positive. 1/2 the size, and then it's minus 1 times the row, or just minus the row. And then spaces plus plus, and I didn't put my comparison in there. The comparison is that spaces is less than or equal to this. Open brace, and then we're printing a space. So system.out.print space. And again, I have an error up here. It's because I don't have my comparison. The comparison is that row is less than or equal to that. Okay, I also notice I'm making mistakes, so that's okay. Everyone make mistakes, and especially as we get tired. I've gotten a little tired, so now, not as accurate. Okay, so there's no way to check this is the problem. So if I run it, because I can't see spaces being printed, I have no idea if that's right. So what we could do is go back to our code here. Instead of trying to do the rest of this code, if I just print a single print line statement with 1 /, it would at least sort of see, did I set this up right? So up here in base, after this spaces loop, I'm going to do a single print line statement. I'm going to print a /. I was trying to think if I needed an escape sequence for that. I don't. I need an escape sequence for the \. And I always confuse the two. So, okay, so that worked on size 2. And then we want to check if it works on size 4. It did. And then we want to check if it works on size 6. When I say work, it's matching the figure that we're given over here. Okay, but we don't just want 1 /. We want /s to be dependent on, well, it looks like they're also dependent on the size and the row, just because I just wanted more. Why not? So we'll go back over, and now we're looking at our /s. So I have size and row and /. Size 2, there's only 1 row, and there are 2 /s. 1 row, 2 /s. Size 4, there are, I believe, 2 rows, so I need to separate that out. And there are 3 and then 4 /s. 3 and then 4. And size 6, there are 3 rows, I'm assuming. 1, 2, 3. And it should go maybe 2, 3, 4, 4, 5, and 6. Okay, so again, I'm going to kind of cheat. And what I mean by cheating is I'm going to look at sort of size versus /. the first, how many there are in the beginning. So if I have size 2, 4, or 6, there are 2, 3, or 4 forward slashes on the first line, on the first row. And so what this tells me is the slope, because as these change by 2, these change by 1. So the forward slash is going to equal, the slope is going to be a half times the size, and then, you know, plus something. And the something is going to be dependent on the rows. So one thing we can do is just think about what half the size is. So over here, half the size would be 1. And then here it would be 2. And here it would be 3. So if I start with 1, and I have 1 row, but I want 2 forward slashes, well, 1 plus 1 will equal 2. If I start with 2 here and I add 1, I will get 3. Or 2 plus 2 is 4. 3 plus 1 is 4. 3 plus 2 is 5. 3 plus 3 is 6. So similar to the last one with the spaces, instead of subtracting a row, we're going to add a row here. And again, the quote-unquote y-intercept with this would be 0. The slope here would be 1 for the rows, and because you're 1 times the row, and the y-intercept would be 0. But just to save us some time, I'm just going to do it like that. Okay, so back over in Eclipse, that loop, I still am going to have this print line statement at the end, and now I'm going to have a loop after my spaces loop that says for integer, let's just call it forward, starts at 1, and forward is less than or equal to, again, it's half, so 0.5 times the size. And then instead of subtracting the row, we're going to add the row. Not equals the row, add the row. And then we need to increase the forward by 1. And then we'll have an open brace, put my loop in, and then what's happening in this loop? We are printing a forward slash. And that should work. Let's run it at size 6. Should have 4, then 5, then 6 forward slashes. 4, then 5, then 6. Looks right. Hit it at size 4. Notice, you know, this is a bit tedious, but, you know, this is how we are making sure that it's working. That looks right. And then size 2. And you can tell by the length of this video, the 3 videos, you know, this is not a quick fix, right? It takes some time. I think I will leave the rest of it to do for you, because what's left is to figure out how many percents there are. And again, those percents, they're not dependent on the row. We have the same number of percents for each thing. And then we have the backslashes, and the one thing about the backslashes is to print a backslash, you need an escape sequence. So when we go to do our backslashes, that print statement actually has 2 backslashes in it. That will print 1 backslash. That's the escape sequence for it. Okay, so, but the quantity of backslashes is the same quantity as the forward slashes. So the loop will be exactly the same. It just changes the, just change the print statement inside of it. So that should be pretty quick. Same thing with the percents. Maybe we should just do it. I don't know. I'm just tired. Let's do the percents. Why not? Because the forward slash is going to be easy. So the percents is just dependent on the size. 2, 4, 6. I think in size 2 we have 3. Yep. And then 5 and then 7. 3, 5, and 7. Hopefully we're getting good at recognizing the slope. This goes up by 2. These goes up by 2. So the slope is 2 over 2, which is 1. The y-intercept, if you go back to 0 here, that's going to go back to 1. So the percent will go from 1 to, inside there is going to be the size, 1 times the size plus 1. Where is that happening? It's in base. And it's below the forward slashes. So we have another loop here for integer percent. Starts at 1. Percent is less than or equal to size plus 1. And then percent increases by 1. And then we're just printing a percent sign here. System dot out dot print quote percent unquote. Close it out. Good. Then we need our backward slashes. So I'm just going to copy these 3 lines of code and paste them in below my percents. And we're going to change forward to backward. For backward, because it's the same numbers, so the same quantity of forward slashes as backward slashes. So all we should have to do is do the same loop, but instead of printing the forward slash, print a backslash. But to do that, we need 2 backslashes for the escape sequence. So I'm glad I continued because I think we now are done. There's size 2. Oh, look how nice it is. And then we need to check it at size 4. There it is. And we can check it at size 6. There it is. We could check it at size 16 if we wanted. I mean, there's nothing to check. It's just to see if it works. Whoa, it's cool, right? Yeah, fun. So go back to 6. You know, maybe we want this print statement at the bottom. So I don't have that. I could put it in at the bottom of base, or I could put it in main. Let's just put it in main, since it kind of is dependent of the base. System.out. Oh, I think I might have said, I don't think I said main can't have a print statement. We're going to put one in here. Print line, quote, size equals space. And then we can add here size. We could also have put that in as part of the base, but that's sort of up to the user. It might be a little cleaner, but because it's not really part of the base, I thought maybe it should just go on its own thing. One of the assignment that you have that's like this, I asked you to copy all 3 sizes. So you would highlight your whole console here, copy it, and then you can do it in Notepad. If I open Notepad here, it allows me just to create a text document. So I could just paste it in. There's size 6. Sometimes if you paste into, well, I know if you paste into Canvas, it doesn't work. Sometimes pasting into Word, it messes up the spacing a little bit, so it's harder to see. But Notepad's a nice place to do this in, because it'll maintain our spacing. I need to hit return after that. Size 4, and then I'll do size 2 above it. So what I'm asking you to do there is to copy all 3 sizes out of your console into a text document. I'm just copying and pasting. I'm hitting, I should have started with size 2, but I didn't. Size 2, size 4, size 6. And then after that, you write a brief reflections journal. And that's talked about in the assignment. We're going to do that on a lot of the stuff that we do. Okay, so this code was fun. It went on a little longer than I thought. I want to go back to the idea of main and our code consisting of 3 parts, top, middle, and base. The top was pretty straightforward. The middle had more components. Also, there was some functions that we could put in here to avoid redundancy. Notice there's nothing that's copied. There's nothing that's exactly the same in any of these functions. So we've avoided all our redundancy. In base, you know, these loops themselves could have been functions, but you know, it's just one loop. So the function, calling another function there just makes it maybe clearer to see what's happening. But because none of those things are happening more than once, we don't really need individual functions for them. And again, I will post this code along with the 3 corresponding videos. And that will sort of run us out of chapter 2, and we will begin looking at chapter 3. Nice.